So correlation and regression. So correlation. So first, let us try to understand what is correlation. Correlation is a standardized format because when we put a regression equation, it is just derived from correlation. Unless I find out that there is a correlation between my dependent variable and independent variable, ideally I should not go and find the next step, build the regression equation. So ideally for each dependent variable, my dependent variable with each independent variable, first I should find out whether there is a correlation. Then only I should build my model. So so what does again correlation means? Correlation is standardized covariance. Then the question is, what does covariance mean? Covariance means, like the name suggests, covariance. How does two variables vary together, right? Whether they move in the same direction or opposite direction, or there is no relationship between their movements, right? So if you look into the formula, so xi bar, let's say my one of my variable is x, another variable is y. The difference, average distance from the mean for each of the values. Similarly, distance from the mean for the y values divided by n, sample number of samples, number of data points. That gives me the covariance data, covariance information about the population. Like, for the sample, we divide by n minus 1, sample size minus 1. Then if I have covariance data, covariance information, with that, if I divide by the standardized x, standard deviation of x and standard deviation of y, then just a moment, I call. Okay. So correlation is the standardized covariance, right? For standardizing our covariance, we are dividing it by standard deviation of those two variables, right? So if your correlation, here we are talking about two continuous data, two continuous variable, let's say age and income, right? So if I believe, if my logic is that with your age, your income will increase, monthly or annual income will increase, right? So that is where I'm trying to build a correlation between those two variables, right? And I calculate and it comes, let's say 0.8 or 0.9. What will I take? They are positively correlated. That means when age is increasing one direction, your income is also moving in the same direction. They are varying together. They are varying in the same direction. Opposite might be true, right? So as our age increases, our mobility decreases, right? So from the childhood to the teenager, youth, then middle age, then old age, right? At different stages of our life, gradually our movement or the like kind of mobility decreases, right? So in that case, what will happen? The effort or the mobility, if I can put it in a number, and our age, both are in the opposite direction. The movement are happening in the opposite direction. So this is when this number is varying from -1 to +1. In between, 0 might also come. So -1 means they are moving in the opposite direction. +1 means they are moving in the perfectly in the same direction. Then the question is, what does 0 mean? If I find out that the correlation or Pearson's R, that correlation coefficient, this whatever calculation I'm doing, is, let's say, 0.001, very close to 0. What does that mean? If I'm getting a correlation value is very insignificant, very close to 0, what will it mean?
Positive correlation, but correlation is very weak.
Okay. So can I say that there is no relationship?
No, sir.
Very
When
less relationship. Right?
Okay,
sir,
let's
both
say
are
it is,
negligible.
if it is coming is 0, let's say it is
So there
coming
is
is,
no strong relation. So there is no strong relation between both the variables.
okay. Yes, Abhijit.
Sir, even if the correlation is 0, that doesn't mean that the variables don't have a relationship. There could be relationship, but the relationship is not linear.
Yeah. So correlation coefficient, it is the one which the formula is given, right? This formula measures the linear relationship, right? So what does it mean if I have two variables? Let's say your economic growth rate with the oil prices, right? all the crude oil prices, economic growth rate. It need not be necessarily a linear relationship, right? So we might have to do certain data transformations. It might have a exponential relationship or a polynomial relationship. So when you talk about linear relationship, can I build a linear equation with it? Can I build using these two variables? If I can say that economic growth rate is some ratio or some value multiplied by your oil prices, that becomes a linear relationship. When we are building this correlation, if the correlation coefficient is becoming zero, this R value is zero, right? That doesn't mean that they do not have a relationship. What does it mean? They do not have a linear relationship. Then I have to look into what kind of other relationship, whether if I make it into oil economic growth rate is equal to some parameter multiplied by oil prices to the power q, right? Or logarithmic of oil prices or exponential of oil prices, right? In that case, there is a relationship. It might be exponential, it might be a logarithmic, it might be a polynomial, or it might be inverse transformation. Some different type of relationship rather than linear relationship, right? So correlation coefficient zero doesn't mean that they do not have a relationship. It only means that those two variables which we are trying to find covariance, right, or correlation, right? So they are not linearly related to each other, right? So I cannot build a linear equation using that, right? Is this part clear?
Yes, sir.
Yes, sir.
So now though, let's say try to build a regression model. I'll show you obviously in Excel. Just try to show that how this regression equation for a simple yes, Abhijit.
Sir, my question is that why do we use the least square methods? We could have taken the absolute, the mod value to calculate the errors, right? Sum of errors, and then
Sum of errors will become zero. There is a chance that sum of errors if you take a absolute value. So actually what is happening? Okay, you are taking modular value. Modular value if you need to take, so you are highlighting, bro. The more the distance you are making sure that the model, let's say if there is certain outlier, your value is average value is 5, your some there are outliers is 25 or 20. Mod value will be what much? 20 minus 5 is 15. But if I'm taking a square of that, it is becoming 15 square of that 225, right? So it is going to penalize your model. If you do not consider only modular value, it is just taking the
Yes, sir.
absolute value. Distance will be averaged out. But if you are taking a square value, if there are outliers in your model, the model will get penalized. So that's why
Okay, sir.
it
So
is
the extreme values, you want to penalize them so that the model
yes.
behaves accordingly. Okay.
Model takes care of that. So otherwise,
Yes.
what will happen? The difference is if I take a build one model where there are values 10, 10, 10, like most of the values are 10 or close to 10, the average distance, and there is one or two values which are very extreme 20, 25, 30, 38, or 100. So what will happen? Your model equation will change, right? So model equation will take care of the extreme values because the distance will now what will become? If let's say there is 1.100 and my average value is 20, rather than the absolute distance becoming 80 square, it is becoming 6,400, right? So it is
Yes,
going
sir.
to heavily penalize your model.
Yes, got it.
Who else was asking another question?
Sir, no, I was asking the same.
Yeah.
question.
Same question.
Yes, sir. Yes, sir.
So, so let's say I have carried out a survey of finding out attitudes towards city, right? So in a scale of 1 to 11, 11 means that person is, if that person is rating it as 11, that person is very fond of that city. 1 is do not like that city at all, right? I have another variable, another two variables actually, but in this model, I'm going to use only one variable, one dependent and one independent, right? Other variable which I have considered is duration of residence, right? So how many years that person has stayed in that city, right? So if I want to build a regression model, first I have to find correlation. There is a direct formula of correlation, but I prefer to find covariance and take a correlation formula out of that, right? So that is a easier or logical approach. So how I find out covariance, how those two variables are varying together, right? I find the average of this attitude for 12 respondent, that becomes 6.58, average of these numbers, right? Attitude numbers. Duration of residence 10, 12, 12, like this. I take the average, it is becoming 9.33 years, right? Then I find out attitudes towards city, the distance from the average. These are the individual values, right? Then xi, duration of residence, distance from the average value, xi minus x average. Then take the multiplication of that. Now I'm trying to find out what is the how much variance is happening together, right? So I'm multiplying those two values together, right? So this is the xyi minus y average, xi minus x average. That means minus 0.58 multiplied by 0.67. These are the values I'll get, right, for 12 respondent. Add them up, that will become 179.67. Because I'm finding it for a sample, if I divide by 11 rather than 12, because total sample size is 12, but I am going to divide it by 11. Why 11? Because this is a sample of the population, right? It is not that all the respondents are like there are only 12 respondents in the city. I'm only taking 12 respondents for my survey, right? So that's why I'm dividing by 11 rather than 12. So that gives me 16.33, right? So once I know covariance, if I know standard deviation of y and standard deviation of x, I divide by that. That will give me this correlation. So I find these two variables, attitude sparsity and duration of residence, are positively correlated and they have a high linear dependency, right? Once I know that, I'll go and build the regression model. Linear regression model, simple linear regression model. Y, my attitude towards city, is equal to some constant plus some coefficient b multiplied by duration of residence. So my idea is to find out this b, right? Because x is given, y is given. I have to find out a and b, right? The formula of b is for a simple linear regression. That is, b is regression coefficient is equal to correlation coefficient between those two variables multiplied by standard deviation of y divided by standard deviation of x, standard deviation of dependent variable, standard deviation of independent variable, right? So this is the formula of your regression coefficient which you use in your regression equation, right? So that gives me a value of 0.589. If I substitute this by 0.589, so my equation becomes y is equal to a plus 0.589x. So y value I know the average value, that is 6.58. X average value I know 9.33. If I substitute those numbers in this equation, my a value becomes 1.079, right? In Excel, if you put within few seconds, the answer will come, right? You need not have to do these many calculations. So I have got an equation y takes about 1.079. Let me assume that number is 1, right? Plus 0.6 rather than 0.589. Let's say this is 0.6. So my equation is basically y is equal to 1 plus 0.6x. So how do I interpret this? For each year of residence, the person's attitudes towards the city is improving by 0.6 point, right? Now my question is, if that is my equation, if somebody has stayed 20 years in that city, what will be the attitudes towards the city? If my equation is 1 plus 0.6x,
We will put x equal to 20.
so what will be the answer? 20 multiplied by 0.6, that is 12, plus 1, 13, right? Is this correct or not?
So 14.33.
14.66. How did you get that number?
So 1 plus 20 into 0.6.
20 into 0.6, what will be the answer?
It's I think 13.
20 into 0.6, 13. How do you get that number?
So 20, it's 12. Sorry, sir. I did 0.66. Sorry.
So 12 plus 1, 13, right? So
13,
my
13, sir.
y is becoming 13. Now the problem, what happens, my attitude towards it is measured in terms of in a range of 1 to 11. So then what does this 13 mean? I do not have a value of 13. I have only the range of 1 to 11. So now what does 13 mean? Everybody is getting the issue or the question what I'm asking. If I put the duration of residence as 20, my y value, my attitude towards it is becoming 13. But I have only 1 to 11. My range is 1 to 11. Now how will I interpret this? Anyone? This is the most important concept in regression, right? Most of the times we skip it. regression is valid within the range of your independent variables, right? So that equation what I built, right? This 1.079 or 1 plus 0.6x is only valid within the range of my independent variable. Which is my independent variable? X, duration of residence, that the range is 2, the minimum value is 2, maximum value is 18. So this equation is valid. So if you have built an equation in your Qt project, those will be valid within the range of whatever independent variables you have taken. You cannot predict something beyond that. That equation won't remain valid, right? So in this particular case, the same issue. I do not have a value greater than 18. So anything, if you give me a value between 2 to 18, I can predict what is the attitude stressity. Below 2, above 18, my answers will not remain valid, right? I will not be confident on my answer, right? Is this part clear, or anybody having any doubt on this? Yes, Abhijit.
Sir, even if you take 18, then it's 10.8 plus 1, 11.8, and it's exceeding 11, right?
What is 18.0589, right? So yes, it will be 11 point something, right? Close to very
Yes,
11,
sir.
right? Ideally, it should be within the range. So
Yes.
if you are getting some answer greater than 11, it will be like discarded. You cannot take that.
Okay, sir. So both have to be within the ranges.
Yes.
Okay.
Within between 2 to 18.
So that
Okay.
means that the boundary points will never come inside the range. That 18 or 2
Yes.
will
Yes.
both. Okay, sir.
Anything between 2 to 18, that is the it is a open. Sorry, it is a closed bracket. When you build that range, it is a closed bracket, not open bracket. So if you have, let's say, 5 independent variables and I want to predict, let's say, importance attached to weather, my range is again whatever 1 to 11, right? So that is anything. Any other variable also I take as independent variable. So my regression model, if I'm building, so that is valid within the range of those independent variables, right? I cannot predict anything if I have a value, and that is somewhere the mistake happen in most of the prediction models. They are trying to predict something which is for which they do not have the initial training data, right? And that is where the most errors or squared errors happen, right? So this is one major concept. Your regression equation is only valid within the range of your independent variables, right? And other two concept I'll show you in Excel. Okay, quickly jump into Excel. Let me share the file with you. So I put this in chat message, session 8 correlation and regression. Please open that file. Okay. So let us first try to solve the first correlation regression question, then we'll come back and discuss some concepts. So now we have already built in the slide a simple linear regression. Simple linear regression means bivariate regression. I have only two variables. Now what we'll build? We'll build a multiple linear regression. Okay. So my problem statement is, so these are TV programs, serial ones. So there are different TV serials. There are around 38 TV serials. I have got the revenue earned by the program. How does this TV serials earn revenue? In between there will be advertisement, right? So advertisers will be paying to the TV channel, and TV channel will share some of the revenue with the TV program. The more like, let's say, IPL being broadcasted in Sony Live or any kind of channel. So the advertisement during IPL, some part will be given to whichever the channel partner, and some part to the IPL, right? Same thing with any kind of TV serial, right? So that is how they earn revenue. More popular the TV show, more revenue they will be earning. So that is the revenue earned by the program. So serial one, they are earning per program 1 lakh 19, sorry, 11 lakhs. How much this? Yes, 11 lakhs 97,576 rupees, right? What is this P? P is the amount of money spent on promoting that program, right? Because you also have to promote that program in your social media, YouTube, and all those things, right? Because unless people will not know that there is a new program or new TV serial, right? Then CTRP is the TRP rating, the popularity rating of that TV program, right? CTRP means cumulative, like your GPA is getting cumulative, aggregated, right? So this is per week or per month. This is the aggregated value which is given. So I have three variables: my revenue earned by the program, my program budget or the program like kind of promotional budget, and CTRP ratings, right? Now, obviously, first I have to write my alternate hypothesis. My research objective is to understand like the dependency of R, whether revenue is dependent on this TRP ratings, CTRP ratings, cumulative TRP ratings, and promotions, right? TV promotions, right? So, what will my alternate hypothesis? If my research objective is to understand the dependency, right? How does revenue is dependent on CTRP and P? Sorry.
Sir, revenue is dependent on promotion and TRP.
Okay. So R is dependent on P and CTRP. Right. Then my null hypothesis will be R is not dependent, right? So that is the status quo. There is no relationship. R is not related to P and CTRP. Study M basically dependency of. So at the end, regression means I have to build equation dependency of R on P and CTRP, right? Then my variables are revenue, promotion, CTRP. My dependent is revenue. My independent is P and CTRP, right? So this is it. Now I'll go and just put a regression model. So I think all of you know this. Go to data, click on the data analysis. There is something called regression. Click OK. Select your input Y range. That is my revenue is my dependent variable. Input X range. Select both CTRP and P. Right. Labels output range 18. Okay. Writing data output range. Okay, so this is some statistics I get. So let us try to interpret this or understand this. What does this ANOVA table say? How to interpret this? What does this ANOVA table talks about?
Sir,
Yeah.
can you go to the typing? You have the type that how to create that the formula you have written. I was downloading the Excel sheet in another laptop now, so I unable to see it at that time. What were you typing at that time?
What in the data analysis?
No, sir. The regression I know, sir. Before typing, you have written something in what typing na in the Excel sheet. I am asking about that.
This ones.
Yes, sir. Yes, sir.
Yeah. So anyhow, I'll share the slide. I'll share this Excel files. So if I've not written, that is okay. You can go through it. So basically, what I'm writing, what is my alternate hypothesis? What is my null hypothesis?
Yes, sir.
So you know that how to put in data analysis regression, right?
Yes, sir. I know.
Yeah. So just select your R, that is your dependent variable. P and CTRP is your independent variables. Now my question is, what is this table and what is this table and what is the difference between these two tables? What is the information or what is the insight we'll get from these two tables?
Sir, from the first table, we can find out the number of from the first column, that is the DF column, we can find out the number of variables from the regression one, how many
Okay.
variables are present.
Okay.
The second, we can find out the number of data set we have from the total number of data set that we have in our variable, and then we can find out the significance level, that if our data is significant, like is it dependent or not, significant enough.
Okay. So he is telling it this number which is significant. This is a very minus 14, e to the power minus 14 means 0.00013
Sorry,
then 2.
exponential data.
Yeah, 2.79, right? It is not exponential, it is basically 1 divided by 10 to the power minus 14, right? 10 to the power 14, right? So that is where e comes into picture, right? It is not e to the power. So that is a small e. Because they cannot write that many zeros, this is where you put e to the power, capital E to the power minus 14. That means this number divided by 1 to 10 to the power 14. So 0.0013 zeros, then 2.79. That basically means it is a very low number, very small number, right? So now my question is, so you said that the data is significant, right? Any other answer?
Yes, sir. Sir, as the significant value is less than 0.5, so we will consider that the hypothesis we have considered is significant and
Okay.
related.
Okay. So Abrar is telling this: if we have this value less than 0.05, then we can believe that our like kind of whatever null hypothesis or alternate hypothesis we have taken, then we can make certain claim about it. Yes, Abhijit.
Sir, if it is less than 0.05, then it is significant and we will reject the null hypothesis and accept the alternative hypothesis. That means R is dependent on both the independent variables.
Okay. So this ANOVA table talks about your overall model. Remember why you are doing this hypothesis testing? We're taking, so that doesn't mean that we have only 38 TB programs, right? Whatever TB programs we take, this model what we are building, right? So this ANOVA table talks about whatever our hypothesis is, right? We are able to reject it for our population, right? Null hypothesis R is not dependent. We are rejecting that for our population. That means R is dependent on promotion and CTRP, right? So this table talks about that, right? Always remember, within the range of this equation will remain valid within the range of my independent variables, right? So what is the minimum value? 75,600, maximum value. This one. Then TRP ratings. So this model which I'm building, right, going to build will remain valid for the population within the range of my independent variable, that is promotional budget from this to this, and my CTRP ratings from 90 to 156, right? Now what about this table? What does this additional information this table gives us? Yes, Abhijit.
Sir, the intercept is it is 37. H37 is the intercept, y-intercept. Y equal to a plus b1x1 plus b2x2. So this is a, and 38, H38 and H39 are the coefficients of the individual independent variables.
Okay. What else?
And
What other information will get?
It's a p-value. If it's less than 0.05, we can consider that independent variable to be a significant contributor to predicting y. If it's more than 0.05, we shouldn't consider that.
Yes. So what it means, if I'm building this regression equation, what will my revenue? R is equal to intercept, that is constant value 41008.8 plus this coefficient is, so I'm building a linear equation, right? 5931.8 multiplied by CTRP plus your 3.13 multiplied by P, right? So what I'm telling, this revenue equation, obviously for the sample within this range is true, right? But if I take another sample within this range, some other number, some other value, some other CTRP rating might come between 90 to 156, this number to this number, right? Now what I'm telling, this equation which regression equation I'm building, out of that my intercept is not significant. This p value is 0.65. So this constant value will not remain true in the population. If I take another sample, I do not have confidence that this value, whatever 41,008, generally we do not put lot of weightage importance on intercept. But other way of looking here, if I have, let's say p value was less than 0.05, then I should have taken that. Now what I can say, this for my sample, this equation is okay. This value is what I've got, this value is okay. But if I take another sample, I cannot guarantee that this number, I will not have confidence on this value 41008.84. But because this value 5931, I have a very low p value, right? I am very confident on this number. I have confidence on the CTRP coefficient value. I am very confident on this p value, right? Which is 3.13. But I am not confident on this because this is 0.654. It is a very large p value, right? So this equation will remain valid for the sample, but for the population, I can with guarantee I can say that my interpretation will be like that. For any change in your whatever CTRP, right? Keeping p same. Okay, tell me how to interpret this. So when I say that 5931.8 multiplied by CTRP, what does it mean actually?
So 5931.8 means that for 1 unit change in CTRP, the revenue will change by 5931.8, keeping all other independent variables constant.
Yes, so that is the most important part, keeping the other variables. So other variable here is only one variable, that is P. Same, 1 unit change in your CTRP will improve, increase revenue by INR 5931. So anytime you are talking about regression, right? So we are basically talking about irrespective of other values, keeping other variables same, right? If I change my CTRP, right, there will be change in 5931. How to understand it? Let's say I have two programs, right? They both of them have same promotional budget, right, from the same producer. For both the programs, he is putting 1 lakh rupees per promotion. Other program also 1 lakh rupees per promotions, right? In social media and other things. So promotional budget is same. For one program, let's say CTRP rating is 100, other program CTRP rating is 99. So the program which have a CTRP rating is 100 is going to earn 5,931 rupees more than the other program which has a CTRP rating of 99. Because for them I have kept the promotional budget same. If my promotional budget are different, then obviously the total revenue earned will be different. Keeping the promotional budget for both the programs same, if I am comparing those two programs, right, my revenue earned by the program which have a CTRP rating of 100 will be more than the other program which have a CTRP rating of 99 by 5,931 rupees. Similarly, if I interpret the other variable, right, keeping the CTRP same, that means if I have two programs which have both cumulative CTRP rating same, let's say 100, both the program have a cumulative TRP rating is 100. So one program, if I put 10,000 rupees, another program where I put 20,000 rupees, so I'm putting more than 10,000 rupees in another program, right? The more advertisement, the revenue earned will be 10,000 multiplied by 3.13, that is 31,300 rupees. So what does it mean? For each unit of money invested in a program, I'm going to earn 3 rupees 13 paisa. If I'm putting 10,000 rupees more, I'll get 31,300 rupees more, right? So this is how we interpret our regression coefficients. Is this part clear, or anybody having any question? Yes, Abhijit.
Sir, I have two questions.
Yeah.
The first question is, let's assume the p values of the intercept and all the independent variables are well below 0.05. Then we can generalize this linear regression equation to the population. But so what if the significant f value is more than 0.05? What does it actually mean?
Which one? This one?
Yes, sir. Yes, sir.
Yeah. So your model will not work. Your model is invalid. Your model is insignificant. So you cannot.
Sir,
yeah.
Is it insignificant for the sample as well, along with the population?
Yeah, that itself your R square value will be very low, pretty low. So if the significant value is less than greater than 0.05, R square value anyhow will be there. Any you take any variables, it will be 5%, 10%. You'll say that okay, my model is only explaining 10%. Whether you will
Yes,
go
sir.
and consider that model. If this value is coming greater than 0.05, let's say 0.2, 0.3, your R square value automatically will become very less. So you are telling that, okay, I'm building a model, but I can only explain 20% of the variance, 20% of the variation in revenue. That is a very poor
Ah.
model.
So that in case, so sir, in this case, when f value is more than 0.05, the linear regression equation is not even able to explain the variations in the sample as well.
Yes.
Okay. And
This
sir,
model is
one more
no,
question.
yeah.
Yes, sir. Yes. Sorry.
This model is no longer significant. So your equation also most of the time, if this is becoming insignificant, 99% of the time, this p value also will become insignificant. Your R square value also will become very low, right? So neither you are able to explain in your sample. Obviously, if you are not able to explain in sample, there is no question of population.
Right, sir. Right. And sir, one more question. So, sir, whenever we do any calculation, any hypothesis testing, we're always doing it mostly on the sample. So every time the denominator has to be n-1, right?
Yes, for most of the cases, yes.
So, sir, in Excel, is it coded like that? The denominator it will take as n-1.
N-1 where? When you are doing correlation
To
regression,
find the
right?
covariance. Yes, yes.
Yes, yes, yes. So we'll put covariance. So covariance per population, covariance per sample. If you put sample, it will take n-1.
But sir, we just selected the regression option from data analysis. So did it understand that it has to do the
Yes,
covariance?
obviously, obviously.
Okay, sir. Okay, sir.
Yeah. So that is already inbuilt. You do not have to worry about it. So now what is the difference between these two, R square and adjusted R square? Yes.
Sir, R square is the square of the correlation coefficient, which explains it explains the percentage of the total variability that is in the data set. The data set has data points scattered around. There is a lot of variance among the data points. So R square will explain. R square will tell us this linear model that we have built, this linear regression line, what is the percentage of the variance that can be explained by this model.
Correct.
And I'm not sure about the adjusted R square.
Okay. So anybody, so what Abhijit told about R square is correct. So if I'm building this model, I'm telling that revenue is dependent on promotional budget and CTRP, TRP ratings, right? By taking that equation, how much variability in your revenue I can explain by creating that model of R equal to that whatever equation I told, right? So that about your R square is talking about, right? How much variation, right, in your revenue I can explain by using this model, right? Think about in this way, normal term. If I can predict somebody's salary, right, or if I can like if I talk about human resources, one of the biggest challenge the IT companies is facing, they can predict somebody's percentage of chance of attrition, right? What is the chance that that person is going to leave the company, right? From 0 to 100. 0 means he is not going to leave at all in the next 3 months. 100 means obviously he's going to leave the company, right? So there will be different independent variables, number of years he has worked, number of performance ratings, number of salary increase he has got, his managers. Yeah. There are a lot of variables, right? So using that, if I'm able to create a model and I'm able to tell, obviously suddenly is like something happen, some employee can leave the company, right? So that is not in my control. That is certain things which is happening due to randomness. But if I am able to build a perfect model and my R square is around 90% or 95% good, good value, then what I'm basically saying, that person's attrition, the percentage of attrition or the probability of that person leaving the company, I can predict to 90% extent. So I'm very good. So his explainability of model is such that 90% of the time I'm able to explain why employee is going to leave the company, right? Obviously, it cannot be 100% because there will be certain regions which is not built, certain factors which you have not taken into your model, right? So R square cannot become your one. One means perfect, you can know why a person is leaving, all the components you have taken care, which is not true, which is not possible, right? But to the extent, let's say 60%, 70%. So you know the 70% like chance, you can predict with accuracy that why a person is going to leave your company, right? So that is where explanation of your model is given by your R square value, right? Now what about adjusted R square? Yes, Abhijit.
Sir, will R square be highest for the best fit line?
Yeah, that's why we're taking that best fit line, right?
Yes, sir. Sir, even if we found out the best fit line and the R square is suppose 40% or 50%, then there is a lot of variation that our model cannot explain. So
Yeah,
in that case, what we should do?
then I did not get to. Then what you should do?
Yes, sir. Should we change the sample? Then what we should do?
Then your model, you have not taken correct independent variables. You have to look for what other regions might be there. If I want to predict like what the chance of the person getting COVID, if I take only certain factors, age, the location, the like person's like health, like status, and I'm able to, let's say R square is 0.6. So I can guarantee like 60% explanation of somebody is getting a COVID or not, I can explain. That means I have not taken certain other important variables in my model.
Yes, sir. Yes, got it.
So then what does adjusted R square means? The problem with R square is like what Abhijit was asking just right now. Sometimes what might happen if let's say my R square is small, 0.40. Now a researcher what will do? He'll add some additional trial and error basis, will putting some independent variables. Sometimes R square will increase without any logic, right? Let's say somebody getting a COVID or not. It is not anywhere related to that person's, let's say, salary, or that person's, let's say, which kind of job that person has. Might not be related, right? I'm just giving an example. There is not, let's say, there is no logic behind it, right? And if I put that and my R square is increasing, like that, I'll keep including my unnecessary independent variables, right? And my R square value will keep increasing. Then I'll say that, okay, now I have improved from 0.4 to 0.6 or 0.4 to 0.8. Then I'll say that, see, I have built a very good model in comparison to other students or in comparison to other researchers. So, like I was giving that example, I think in your previous class, there is something called as spurious regression, right? In California, if you search on Google, there will be a lot of answers about spurious regression. In California state, for the last, I think, 90s to 2005 or 2006, they carried out a detailed study. In summer month, they found out the ice cream sales rate and suicide rates, and they found a perfect correlation between them. So if I build a regression model saying suicide rates is some constant plus multiplication of ice cream sales, R square value will come around 0.9. I think they, for them it was 0.92 or something, but there is no logic behind it. So now what happens? I'll build a model and I'll say that, okay, I can build a model and predict the suicide rates, but there is no logic, there is no theory behind it. So this is something known as spurious regression. Most of the researchers fall trap to that. So unnecessarily will build a model without any logic, without any theory. Randomly you build your independent variables. To avoid that scenario, there is some concept called adjusted R square. What does it actually mean? So if I just ignore this value n minus 1, n minus p minus 1, this R square value is same as your adjusted R square. 1 minus sum of square error divided by sum of square total. So this part of the formula is nothing but your R square. On that, what I'm doing, on this part of the formula, sum of square error divided by sum of square total, I'm multiplying one factor called n minus 1 divided by n minus p minus 1. N is number of data points, number of observations, your sample size. P is number of predictors, number of independent variables. So what does it do? Let's say I have 100 observations and I have only one predictor, right? So what will my formula? Let's say this is some value, SS error, SS total, some constant value. 100 minus 1 divided by 100 minus number of predictor, number of independent variable is 1. 100 minus 1 minus 1, 98. So 99 divided by 98, it will come around 1.00 something, right? Let's say I unnecessarily keep adding independent variables just to inflate. Most of the times what happens, if you just add any independent variable, most of the times your R square value will increase by a certain point, right? Whether it is logically dependent or not, it will not look into, it will just increase. Maybe sometimes it is increase by 0.1 per 0.10 or maybe by 0.05. Some value it will increase. Now what I'm doing, anytime I'm adding a new independent variable, I'm actually penalizing R square. So in this case, let's say I have added 9 variables. Now what will be this value? 100 minus 1, that is 99, divided by 100 minus 9 minus 1, 90. 99 divided by 90 is 1.1. So earlier it used to be 1.001. Now it has become 1.1. So as and when I keep increasing by number of predictors, let's say I have 49 predictors. Now what will become? 100 minus 49 minus 1. So this is 50 divided 99 divided by 50. It will become 1.8 or 1.9, right? So now what happens? This multiplication will keep increasing. SS error divided by SS total. This will keep increasing. And if I subtract from 1, that value will be less, right? So comparison to R square, this adjusted R square will be less. So why we are doing this? So that it is basically working as a check that we should not add any unnecessary independent variable. We should not make our model more complex without any logic, without any theory. So this is when we talk about multiple linear regression. That means we have multiple independent variables. We always should look into adjusted R square rather than R square, because adjusted R square penalizes any new predictor or any new independent variables you are adding to the model, right? So whenever if I, let's say I have built a model, I'm telling revenue is like dependent on your CTRP and P. I can build another model. I can say that revenue is dependent on time of the day the movie is or the serial is being shown, who is the lead actor, whether it is a popular actor or a new actor, or the amount of time, whether it is a 30-minute serial or a 1-hour serial, right? So like that, if I build a model, my revenue is dependent on that. So now I have to compare two models. What is the adjusted R square of this model? What is the adjusted R square of other model? Whichever has the highest adjusted R square, I should consider that, not R square, right? So adjusted R square is basically to penalize R square whenever you are adding unnecessary independent variable. Is this part clear? Yes, Abhijit.
Sir, this problem that we have, so it has two independent variables.
Yeah.
Suppose I first did a linear regression taking one independent variable, and I found out that it is 0.6 R square. And let's assume that the factor that you showed us, n minus 1 by n minus p minus, it is almost equal to 1, just a little bit greater than 1. And then we took two independent variables and again found out R square, it is 0.7, sir. And if we multiply it with the factor, it will be a little bit more than 0.7. But sir, here, even if we are taking two independent variables, my adjusted R square is less than the first case, right? For the second case. So what should we do? I'm a little confused here.
Second case means obviously it will be less than R square.
For the second case, sir, it will be 0.3, the adjusted R square, because we are subtracting it from 1.
I'm not getting your question.
So for the first case, when there is just one independent variable, we found out
Okay,
that
let us
R
do
square
that.
is
Let us do that. Why you will
Yes.
think on ifs and buts? We just do that data analysis. Regression, I'm taking one variable. Input y range is this. I'll take one variable only. Let me take first CTRP. Labels are there. Then I'll put this somewhere here. Okay. So I get a value of R square is 0.31. Adjusted R square is 0.299, right? Then I take another data, insert data analysis, regression. I'll build with P. Here. Okay. So if I build a model only using CTRP, right? Only using CTRP, my adjusted R square is 0.31, adjusted R square is 0.29. If I build
sir.
an only model with P, my R square is 0.32 and adjusted R square is 0.30. Yeah, now tell me the question, what you have.
So my question was that if we take one independent variable and the adjusted R squared turns out to be larger than the case where we are taking two independent variables,
Okay.
then two independent variables explaining the model is still better than one independent variable explaining the model, right? So, but
So
here
you are
there is
telling you are telling adjusted R square will be more in a one independent variable.
yes, yes, sir. If
No.
that's the case.
Yeah, if that is the case, we'll take. But here that is not the case, right? If
No.
I have a one model with one single variable, let's say this was the case, I'm getting a R square below 0.95. Adjusted R square is 0.95. And here I'm getting adjusted R square is how much? 0.82. Then obviously I'll
Yes,
go
sir.
for the first model with only one variable. Why should I come to a less than adjusted R square?
Okay, sir. Okay, sir.
Whichever model has a highest adjusted R square. Out of these three models, I'll take this one. Let's say this model is not there. I have to compare these two models with P and with CTRP. Whichever has more adjusted R square. With CTRP, I have 0.29. With P, I have 0.30. I'll select this model.
Yes, sir. Got it. Got it.
Now we have discussed R square, adjusted R square. This is the second concept. First concept we discussed, regression equation is valid within the limits of your independent variables. Second important concept is difference between R square and adjusted R square. Whenever you are comparing multiple linear regression model, we take help of adjusted R square, right? It penalizes basically any new variable you are adding to the model. Okay, so quickly we'll do the second exercise. Only change here is we have a categorical variable, gender, right? We have work experience. We want to predict salary. So my alternate hypothesis is salary is dependent on gender. Yes, Anisa.
So when we are calculating adjusted R square, then we are taking into consideration the number of predictors, right?
Correct.
So
Yeah.
in that case, whenever we would be taking one independent variable, the adjusted R square would always be less than when we would take two or three independent variables. Then how are we going to decide on that?
Can you please repeat? If you are taking
So
one
if we
variable,
are taking
yeah.
one variable, then
Okay.
then the adjusted R square should come less, because when we are subtracting it from one, then it is going to come less for one independent variable. But if we are taking two or three, the denominator, that is n minus p minus 1, would be I guess less, and that is how we are going to get more adjusted R square in the case of two or three independent variables. So how are we going to conclude on that?
Okay, so what you are telling, this value n minus 1, if I'm adding new predictors, this ratio is going to increase, right?
Yes, sir.
Okay, so this ratio increases means this number is going to increase. R square adjusted actually should come down. Is that your question?
So, no, sir. So I'm saying that when we are taking two or three independent variables,
Okay, let
this
us
ratio,
take an example.
this ratio would decrease, I guess.
Okay, let us take an example. I have 10 data points, 10 observations. First, I start with only one independent variable, right? So what will be this ratio? 10 minus 1, 10 minus 1 minus 1, that is 8. So 9 divided
Yes,
by
sir.
8, what will be this? Or let me take some other value. Let's say I have 11. Okay, so I have 11. So I'm just trying to make the ratio a little bit understandable. Let's say I have 11 data points. Then I start with how much? Yes, so 11 minus, let's say, two independent variables. Okay, so let me start with two independent variables. So what will be the ratio? 11 minus 1, 10. 11 minus 2 minus 1. What will be the value? 11 minus 3 is 8. 8. So 1.25.
1.2.
Now I start increasing. Let's say I have still 11 observation, but right now I have, let's say, 4 independent variable. So what will be the ratio? 11 minus 1 is 10. 11 minus 4 minus 1, that is,
6.
or let's say 11 minus 5. I have 5 predictors. 11 minus 5 minus 1, that is 5,
2 points.
right? So now what is becoming? 11 minus 1, 10. 10 divided by 5. What will become? 2.
2.
So your ratio is, what is happening to your ratio? Earlier, what was the value?
1.25.
1.25.
1.25. From 1.25 to ratio is becoming more.
2.
So,
Yeah.
right. So when you multiply with this value will increase or decrease?
Sir, increase for more number of variables.
Right, but with a condition. I'll talk to that a little bit later. Believing this ratio is same ratio. Let's say this ratio is some value, 0.8, right? SS error divided by SS total. Let's say this value is 0.8. So initially, what will happen? 0.8 multiplied by 1.25. That is some value, or let's say 0.5, right? So this ratio, let's say 0.5. 0.5 multiplied by 1.25. What is that value? 1.25 divided by 2. 0.62, right? Now what will happen? 0.5 multiplied by 2, that will become 1. Correct or not?
Yes, sir.
So this ratio, if I have only 2 predictors, I'm changing into 5 predictors and I have 11 data points. This ratio is becoming from 1.25 to 2. Let's say this SS error by SS total is initially 0.5. Right, that is a constant. Let's say that is 0.5. So initially, what will be this multiplication? 0.5 multiplied by 1.25, around 0.62. When I have 5 predictors, what will be this multiplication? 0.5 multiplied by 2, that will become 1. My adjusted R square will become 0. Is this correct or not? Adjusted R square actually decreasing.
Yes, sir.
Now the challenge is what we did not discuss, where I am telling you this actually will not remain constant. If I am taking predictors, if I am telling that this predictor is a good predictor, SS error value actually is going to decrease, right? Because I'm decreasing the error in the model. So SS total will remain same, but my SS error will decrease because my this predictor which I'm increasing, if that predictor is actually better, that is a good predictor for your what about my dependent variable? My error in the model will decrease. My prediction error or my that explainability error will decrease. SS error actually, if I have a good predictor, this value will decrease. So this ratio actually will decrease. Earlier it was how much? 0.5. It will come down to 0.3 or 0.2. Right. So now what will happen? Earlier in the beginning case, what was that? This ratio was 0.5 multiplied by 1.25. So it was around 0.6. My adjusted R square would be 1 minus 0.62 is 0.38. Now, once this ratio is becoming 2, and if I have taken good predictors, those additional 3 predictors are actually good predictors. Logically, they are related to my dependent variable. This error will come down and this ratio might become 0.2 or 0.1. So in that case, what will become? This 0.2 multiplied by 2, 0.4, 1 minus 0.4 is 0.6. My adjusted R square is increasing from the previous value, because though even I'm penalizing the model, my predictors are actually logically connected to my dependent variable. They are able to explain my predictor, my dependent variable, right? So when I told you the example, I told this ratio will remain constant, but if you have a good predictor, if you are using the model, let's say for the COVID, you take care that whether they have previously affected by some long disease or not, liver disease or not, that is a good predictor, right? So what will happen? This ratio will actually, error will decrease. Error decreases means this ratio will decrease. SS error divided by SS total will decrease. Is this part clear or not? If you see here, that has happened actually. If I take only one variable, what is my adjusted R square value? 0.29. If I'm taking both the variables together, my adjusted R square is excellent, 0.82. Because both the variables together are able to explain the revenue lot better than with a single variable. Okay. So was that your question, if I understand correctly?
Yes, sir.
Okay. No, if you have still any doubt, you can clarify that. So adjusted R square, I said that what I said is penalizes if you add number of predictors, but that predictor, if it is unnecessary, if that predictor do not add value to your, basically do not decrease your error. Add value means what? It will increase the explanation. It will increase the explanation means decrease the error in the model. If it is not a good predictor, otherwise in R square what happens? Whether it improves or not, it will basically improve your R square value. Whether it is actually logically related to a dependent variable or not, it will automatically increase your R square. So that's why adjusted R square penalizes any addition of independent variables without any logic or theory. Okay. Is this clear or any doubt?
So the first part,
Yeah.
can you please show the equation?
Yes.
Sir, is that R square SS error by SS total?
1 minus SS error by SS total is R square.
Okay, sir. Okay. Got it.
Okay. Anybody having any doubt what we just explained? So study M, you can write dependency of salary over gender and work experience. Variables 3. One is dependent, that is salary. Independent is work experience and gender. Right. Now, if I'm building a regression model, data analysis, regression. This is my value salary. And this is my input X range, that is gender and work experience. Okay, I put labels. Okay. So here also I get adjusted R-square value excellent 0.86. So that means I have a very good model. N over table is significant. This model will remain valid for my population. Then I get this equation. Right? Now if I write in equation mode, my salary is, so all these three values are significant. Three values are significant. That means I can confidently say that this equation will remain valid or significant for my population also, right? 16111.09 minus 17200.2 multiplied by gender plus 2749.2 multiplied by work experience, right? Now what happens? I know that keeping gender same, any change in work experience will improve your salary. Any 1 unit change in work experience will improve your salary. So that I can write keeping gender same. One unit increase in work experience will improve salary by INR 2749.2, right? What does it mean? If I have two employees have same gender, two male employees, the person who has 3 years of work experience will earn 2749 rupees more than those person who having 2 years of experience. If I am comparing somebody who having 10 years of experience with somebody having 5 years of experience, having same gender, male or having same gender of female, then he is going to earn, right? That person, both male employee, that person who have 10 years of experience is going to earn 5 multiplied by 2749.2, that much higher than that person who have only 5 years of work experience. So that means keeping the gender same for each unit, each year of work experience, that person is going to add 2749 rupees into his monthly salary, right? So this is easy, right? This already you have discussed in the previous kind of equation. What about gender? How to interpret this? What does this minus 7 to 200 mean? So how to interpret a categorical variable in regression? So that is the third concept what we are going to discuss. Continuous variable is GG, we have already discussed. Inter CTRP and P we discussed, keeping the other variable same, 1 unit increase. Now we have one categorical variable, gender, another a continuous variable, work experience. Work experience already explained. If both have same gender, both the employees, I can compare their salary, right? and their salary difference will be per year of work experience more, that person is going to earn 4749 rupees more, right? Now what about gender? How to interpret this? Okay, so whenever you have a categorical variable, we have to code that. That is something known as dummy coding. So I have gender, I have two labels, male and female. So then that is up to you. Which one you are keeping 0, that is up to you. I have two labels, male is 0, and you can take male as 1 also, female as 0, but answer will get same. So what has happened? I have considered. So what does it mean? So this person 0 means that person is a male, 2 years of experience, and monthly salary he is getting 14,500. This person, serial number 1, she is a female, coded as 1, work experience 2 years, and she is earning, yes, Abhijit.
Sir, if it's a female, then females will get that much amount of salary less than male. We can only put 0 and 1 there.
Yes, so that coding has to happen in the beginning. When I put this data, you have to
Yes.
put that somebody as a reference. So 0 means what? 0 means you are putting that as a reference label. So whenever you are interpreting a categorical variable, so let's say I have 3 groups. One group you have to put as a reference label. One group you have to put as base label, right? And that is up to you which group. So that is up to you which group you put. In my case, I have taken male as the base label 0, female as 1. So how to interpret this? Keeping work experience same, or let us first write down that equation. So I have two employees, one is female, one is male, and both of them have 2 years of work experience. Yes, Arij.
Sir, in this case, we are having two like categorical variables.
Hmm.
If you are having like more than two categorical variable, can we go for the option of like 2, 3, 0, 1, 2, 3?
No, you have to dummy code that. I'll show you how to do it. So
Okay.
female is coded is 1 plus, so gender value for that female is 1, right? Then 2749.2 multiplied by work experience, 2 years of work experience. So it is coming negative. Sorry, 16,111. Then for male 16,111.09 minus 17,200.2 multiplied by 0 plus 2749.2 multiplied by 2. So if I take the difference, that will be 17,200 rupees. So what does it mean? Keeping work experience same. So if I have two employees who have same work experience, it doesn't matter 2, 5, 10, within that range, whatever numbers I have taken, right? Who is my base level? Male employees I have taken as 0, that is my female base level, right? So now my interpretation will be other label, female employees will earn INR 17,200 less than male employee. If let's say I had taken, so you'll say, sir, if I take, what happens if I take male as 0? Sorry, I have taken male as 0. If I take male as 1 and female as 0, if I just change this, right? So your equation will become plus 17,200, right? So in that case, same. So what will say? Keeping work experience same, male employees will earn 17,200 more than female employees. Result will remain same. How do you interpret also will remain same, only the what like how you write it will be different, right? If I just change it is male to 1 and female to 0, this number will become positive. Result will still remain same. The difference is 17,200. Male employee will earn 17,200 for the same level of work experience, right? Is this part clear?
Yes, sir.
Okay. Now the question is, when we have multiple variables, right? Not necessarily we'll have always two labels. Here actually what is happening, where it is not written here, we are actually creating something called dummy variable, right? So this is a new variable, though it is written as gender. This is actually new variable. This is x1. So how many variables you have to create? If I have two labels, how many labels I have? So dummy variables is equal to how many dummy variables you have to create? Number of labels minus 1, right? So in this case, I have only two labels, male and female. So I have created only one variable, and male I have put as 0, female as 1, right? Let's say I have income group, and I have 3 income group, less than 5 lakhs, 5 to 10 lakhs, and greater than 10 lakhs, right? So now what happens? How many labels I have? 3. How many variables I have to create? 3 minus 1. So I'll create 2 variables, x1 and x2. Whichever one you want to keep it as base, put that as 0, 0, right? Like here I want to keep male as base label, I put 0 there, right? So here what will put? Whichever variable, whichever label you want to keep it as base label, put 0, 0 there. Other one will become 0, 1. This will become 1, 0. Right? So if I want to represent 3 labels, right, I have to put 2 variables here, x1 and x2. This is a dummy x1, this is dummy x2. So I have to create 2 additional variables. So when I'm interpreting, these values will be given, and this value will not be given in the regression equation. So what does it mean? This is always in categorical variable. The interpretation is in comparison to base level. Here, like in work experience, there is no, this is absolute value. 1 unit increase, 2749. 2 unit increase, 2 into 2749. But here what happens? Gender, your female employees in comparison to male employees, it is a relative, right? Same thing here. So when I'm comparing somebody who is earning less than 5 lakhs in comparison to somebody who is earning 10 lakhs, because the base level I have taken as 0, 0. Somebody who is earning 5 to 10 lakhs in comparison to greater than 10 lakhs, right? So base level, again, it is up to you which one you take as 0, 0, both 0. So number of variables, dummy variables, will be equal to number of labels minus 1, right? Is this what you are asking?
Yes, sir. Yes, sir. Thank you, sir.
So this is the third concept. So regression, these are the 3 important concepts what we discussed today. First is regression equation is valid within the range of independent variables. Second, difference between R square and adjusted R square. Third, how to interpret a categorical variable, right? Or how to like create an equation for categorical variable. Anybody having any doubt on this? Yes, Abhijit.
So this system of having dummy variables as number of levels minus 1, is this system only for Excel?
No, no, everywhere.
So because in Python, I had seen that we have to create 3 dummy variables for 3 levels.
So there are around 8 or 9 types of coding. So this is known as dummy level coding. Something is 1 or 10 coding. There is something called reference level coding. There is something called GLM coding. So there are around 9 types of coding. So dummy coding is the most preferred one. But depending upon your question, there are other coding. For textual data, you can have to create that many of variables. If I want to build an image segmentation, that many labels or that many variables I have to create. So,
Okay, sir.
but regression, yes, I have to create.
Sir, one last question. You mentioned a very important point that regression is valid only within the ranges of the independent variables. But sir, this is a sample data set for which we'll do the calculation. Let's assume a situation in which my population has independent variables ranging from 1 to 100. And the sample that I chose, it had only ranges from 1 to 10. So
Correct.
in that case, my linear regression equation that I found out that cannot be generalized for the population.
Correct.
So do I have to ensure that I have to cover the both the
Yes.
minimum and the maximum values?
Yes, for regression model, yes.
Okay. Okay.
Whom you want to predict. So this is a prediction regression. You are using predictive model. Unless you have the range, right? You can only estimate within the range of independent variables. If you do not have the data, sample data, you cannot estimate for the population.
Okay.
So
Good.
if you have not collected correct sample, then you cannot predict.
Okay. Thank you.
Okay, so that's all for today. Chalo, take care. Bye bye.